All right, we're going to work on the second half of lesson 5.3 on scatter plots and lines of fit. We're going to add a couple of concepts today, talking about residual values, which help us evaluate how the line of fit actually meets the data. And we're still going to do some of the concepts we did the other night or last time we met, but we're going to add a little to it. Okay, the first thing we're going to add to it is actually making our own scatter plots. And remember, we this is called bivariate data because we're taking two different concepts and use them as data points. So it's pretty simple stuff. I think you'll like these. The table shows the number of miles run and the number of phone calls made yesterday by 6 people. Create a scatter plot. So, we're looking at our information here and we're treating these like an ordered pair. So the number of miles is like my X value. The phone calls are like my Y. If you look over here, X axis is number of miles, phone calls are the Y axis. So I'm treating this like the ordered pair 3 9. So you'll have a pencil tool. You just come over here to 3, come up to 9, put a point. 5 2, go to 5, up 2, put a point, and you're just going to plot the points up here. And when you're done, you have yourself a scatter plot. Okay. Now, as you look at the scatter plot, and think about the things we've talked about, does this one really show any kind of a correlation? Does it really look like there's a strong positive or negative or correlation? I would say no to this one. Now, they're not going to ask you that question. I'm just throwing it in there. But those are ideas that we've talked about to go along with these scatter plots. So some of your first questions tonight are going to be just this. Go ahead and make your own scatter plot. Okay. The next thing we're going to talk about are residuals and what they are and what we use them for when we start talking about these lines of fit and these data points. Okay, so residuals are going to be the measure of how far the predicted value is from the observed value. Okay, so to calculate a residual, okay, what we'll do is we'll look at the observed value. Now, this is a value that's given in your chart or the value that you can see on your coordinate plane, and we're going to subtract from that the predicted value. Now, the predicted value, is what we would get for that same input, but using our line of fit. And the difference of those two is called the residual. Okay, residual values can be positive and they can be negative. If it's a positive residual value, what that means is the observed Y value is bigger than the predicted Y value. And if you look at it graphically, that means the predicted Y value is above the line of fit. Okay. A negative residual value is when the observed value is less than a predicted value and the predicted value is then below the line of fit. Okay. So let's just look at what we're talking about here. So this table shows a scatter plot. The time people spend watching TV versus the time they do homework for 11 different students. Okay. The equation of the line of best fit is y equals negative 0.3x plus 20.71. Now, this line was created by a program that took this data and got the best possible line of fit, and that's the best possible line of fit right there. That isn't us estimating, although we could, but we don't have to because they're telling us what it is. Okay. Now, our job is going to be to look at some residual values. Okay. The outputs are here, and those are represented in the graph. Okay. So each one of these X's represents one of these. Okay. Our job is going to get some residual values. Okay. It says use the equation for the line of best fit to help fill in the blanks below. Give exact answers, not rounded. So what they're going to want us to do, and we're going to predict or we're going to create these residuals, is number one, they give us the values that we're looking at. So these are the inputs. All right. So the time spent watching TV, somebody watched it for 8.3 hours right here. Okay. When they watched for 8.3 hours, the person that did this, how much time did they spend doing homework? That's the output. That's the Y value, right? You get that right out of the chart, 21.34. And if I go over here to 8.3, right there's that X, right? Well, what we want to see now is how close is our line of fit to that actual answer. So to do that, we're going to take our line of fit, y equals negative 0.3x plus 20.7, and we're going to substitute 8.3 in to say what would the line tell us should happen at this 8.3 input. And it's just a matter of doing calculations. Negative 0.3 times 8.3, add it to 20.71, I get 18.22. So the actual event, the actual person who spent 8.3 hours watching TV did 21.3 hours worth of homework. The line says that a person that watches 8.3 hours of TV should do 18.22 hours of homework. The residual, what we're looking for, is simply the difference of these two, 3.12. That's a value that we want to look at. Okay. Do it again for the 11.9. Okay. So the person who spent 11.9 hours doing homework, or excuse me, watching TV, they did 13 hours of homework. Where's that at? So that's 11.9, like right in here. Okay. Looks like 13. Where's that one at? 11, oh, 11.9 is almost 12. So about 13. So this X is about right here. It's a little bit of ways away from that, right? Well, let's calculate exactly what does the line of fit say for the number of hours of doing homework if you watch 11.9 hours of TV. Well, we're going to plug it in, do the calculations. Okay, this comes out to 17.14. So what's the residual value here? Negative 4.14. Notice we're below the line, so we were negative. Okay, and then do it for the person who spent 15 hours watching TV. Well, they got 19 point hours according to the actual data, the actual process that occurred here. What's our prediction say? Well, the line of best fit says somebody that watches 15 hours should do 16.21 hours of homework, and that's a residual value 2.79. Okay, so that's constructing and analyzing residual values. A line of best fit has a great representation of the data if these residual values are all really close to zero. In other words, the data points fit right on that line of fit. That's a strong line of fit, right? Great representation of the data. When your residual values start getting far away from the line, then it's really not that great of an indicator. Okay. And that's the next thing we're going to talk about. If you talk about a residual plot of data, you're looking at how well the data or your line of fit fits the data. Okay. You can have a perfect model for a set of data, and that's if all the residual values are zero. In other words, there's no difference between the observed values and the predicted values. They're all the same. They're right on the money. Okay. You get a good fit, a good but not perfect model if the following things are true. Number one, the points on the residual plot appear to be scattered randomly with no pattern to them, a few above, a few below. Okay. There are about as many positives as negatives, in other words, above and below, and they don't follow a pattern. There's no clustered fairly close to the x-axis. Okay. And then if you don't have a good model, okay, oops, let me go back here. Oh boy. Okay. Let me go step through this again real quick. Okay. And the line is not good if there appears to be a pattern in the residual plot. And we'll look at that here right now. Okay. So let's interpret these plots. So let's talk our way through this. Shown below are three scatter plots and their lines of fit. Also are three residual plots. Okay, so here's scatter plot A. So you can see the points scattered on here. Here's my line of fit coming down through. There's some above, some below. So these, the difference between the point and the line are the residual values. Okay, over here we got this set of points, this set of data, and that is the line of fit. And then last of all, we have this set of data with this line of fit. So the question is, which one of these residual plots is paired with each one of these? Okay, which scatter plot matches this residual plot? Well, again, look at this one. This represents the residual values. They're all 0, 0, 0, 0. They're all right on the line. So that one is scatter plot B. And then based on looking here, what's the best description for this line of fit? Well, this one's perfect, right? Every residual value is 0, which means every point is right on that line. How about the next one? Well, again, some above, some below. Looks like this, right? Some above, some below. So which scatter plot is this one? Well, this is going to be scatter plot A's residual graph, right? The first point was just below. The second point was just above. The third point was really close. So you match them up that way. What kind of a line of fit do you think this one is? It's pretty good. It's not great, It's not great. This is great. This is okay. All right. And then the last one, well, you can see the line matches this exactly. And there's a pattern to it, right? First of all, we know it matches C. Second of all, there's a pattern to this. And guys, you can see that we go up, then we go down, right? That's not a good uh, uh, what we want to call correlation. It's a really mixed correlation. There's not much we can do. This is not going to be a great representation of the data. Okay. Now, I did throw in some other questions like we had for homework the other day. So, you're going to have some more of those to do where you actually have to write your own line of best fit and then analyze the information given a line. So, some of those are still going to be in there along with some of the new concepts we talked about today. All right. I'll let you have that.